Okay, so for problem number 4 here, what we're doing is we're going to do a lot of the same things that we've been doing so far. And it asks us to draw these two spirals. And they tell us that the only difference between this spiral and this spiral is how wide the turn angle is for this turtle. By which I mean that you can tell here on this picture that the turtle is taking exact 90-degree right angle turns, exactly the same way that we do for our draw square function. And over here we can see that the turtle is taking slightly wider turns, like barely wider turns, maybe a couple degrees at most, and that's causing this weird spiral effect to happen. So what we want to do ultimately is have a single function, a general function that can draw both this and this depending on what angle we give it. So we're going to start by doing all the usual startup stuff. So we're going to import turtle because we're going to need it. We're also going to import this sys module and include this this function here from the sys module that's going to set it so where our code does not cause a timeout when it happens. It's going to raise the limit to 35 seconds because otherwise it could time out and stop running, and that's just a fail-safe that's in there to help make sure that your code doesn't get caught in an infinite loop and lock up your browser, essentially. So we're going to get those out of the way. And then we're going to start a main function. So I'm not going to jump right into trying to write the general function right off the bat, just because if I start trying to write the general function without doing any kind of thinking or prep work first, what I'm going to find is that it's more likely that I'll mess up. So I'm going to instead do a couple of practice spirals first. I'm going to kind of work my way up to building a full spiral, and then work my way from building a full spiral into making a generalized version of that so I can build the spiral on the right. So we're going to very simply just start by trying to draw a spiral. So what do we need to do to draw a spiral like this? Well, let's start by drawing a square. So we're going to use the same instructions that we've done before. We're going to have Alex go forward. We'll call it 20, right? And then we're going to have him turn to the left 90 degrees. All right. Now, let me add in real quick the exit on click method and go ahead and call main at the bottom. Okay, so let's run this. So very simple. Alex draws us a square here. Okay, so what if instead of having Alex move forward the same amount every time, which obviously is only going to get me a square, I have him move a little bit further each time through. So why don't I instead try something like this, where I just pass an I from my range function into here and have Alex do that. So you see it's very small, but if I increase the range here to a larger number, let's say 50, Alex is kind of building up the spiral here. And it's hard to tell because there's theoretically like a 1 pixel difference between each of these lines. But that's kind of the spiral that we want. So obviously, passing an I like this is too small. Now we could do some weird things where we do a range function call here that increases I by different amounts to get this. But there's an easier way to do this, and a way that doesn't require us to build custom ranges like this. What we can do instead is set up a number that we're like kind of happy with. Let's start with 50. 50 is good enough. And we're going to start with a base length that we want our smallest innermost circle or square to be. So this part right down in here. So let's start it at we'll just initialize it at 1. We'll initialize it at 1, and then we're going to use something that we used before, the accumulator pattern, in order to go through and increase this. So with the accumulator pattern, again, we always want to pass the accumulator variable into our pattern in a way where it uses it like this, and then when we're done using it for that run through, we want to increase it. So we can then make length, let's add, we could double it each time, but that wouldn't, we'll start with that. Let's double it each time. That's going to not work for what we want to do here, but let's do it. Okay, so immediately that got out of hand. But that tells me that instead of doubling it and increasing it kind of exponentially in that way, I want to increase it more simply, more arithmetically. So let's try doing it 5 each time. And I actually may need to reload this because I set the execution limit so high that it's just going to kind of keep running there if I don't. So let me reload this real quick. I'll go ahead and load back up my code here. Alright, now we'll run it. So that's close. That's kind of there. It's a little bit wider than we want for this function. So we're instead going to, let's do a smaller number. Let's try 3. That looks about right. That's close enough that we'll call it good. Now I can tell immediately that this is our final product is going to look different than the final product that they're using, because it's obvious up here that they're having their turtle turn to the right, whereas we were having our turtle turn to the left. We can fix that really easily by just, in our for loop here, replacing left with right, and that gets him to go in the same direction, the same clockwise direction that they're using up here. So that looks about the same. It's still maybe a little bit wide, but we'll call it good. I'm not going to count up the exact number of spirals on here. It doesn't super matter, but obviously that's not quite enough yet. We could double it, but it's the act of creating the spiral that's important, and not the actual number of layers here, I think. So now that we have that, we have essentially for loop that we can take out and throw into its own function. So let's create a function. And because we're basing it off of kind of the bare bones of our draw square, instead we're going to call it draw spiral. We'll just call it draw spiral. And then we're going to pass in turtle, obviously. And we'll just leave it at there for right now. So we're going to want to give it a docstring, so takes a turtle, uses turtle t to draw a square shaped spiral. Very good. So that's a good docstring for us. So then we can just take the accumulator variable and our for loop that we wrote down here. We'll just drop that right up here into our definition, making sure that the level of indentation is correct. Alright, so we'll also want to replace our variable names for our turtle, and replace it with the parameter that we used up here, t. Make sure that you replace those out. So now, instead of calling that for loop down here in main, I can just call draw spiral and pass in Alex. And we should get the same output. Very good. All right, so we're almost there. Very nearly there. So then what we want to do is make it so where we can use this program more generally and change the angle. So instead of a 90-degree angle, we want to be able to use a slightly larger than 90-degree angle, which means we need to change this definition, this function definition, to take another parameter. We want to change it so it takes angle as well. And then very simply, we'll just replace our churn with angle. So instead of 90, we'll use angle. So now, if I run this, it will actually not function correctly because draw spiral now requires those two parameters. So let's add in 90. So this should look exactly the same. And then let's try with 93. So I can see now that I did make a mistake. This isn't actually, if you look, it's slightly different. It may look the same at first glance, but it's actually slightly different than this up here, a different pattern. And I bet that's because I used a larger than 90-degree angle rather than a smaller 90-degree angle. I used an obtuse angle rather than an acute angle. Let's see what it looks like if I use an acute angle. That is closer to correct. Yes, that is closer to correct. Still not perfect, not a perfect match because they didn't give us the exact specifications for this. We could try to mess around with that, like if I decrease the length a little bit, I can get it tighter like it looks in there. So that looks close to this up here. Not enough sides, of course, which we can change by, let's change this from 50, we'll just double it. And as he goes here, I should have set the speed to 0 actually rather than 10, so we can just get the entire thing nice and easy, because now we're going to be waiting forever as we wait for this. So I can tell this worked out a little weird, got a little out of hand, which means I think that our angle is still a little bit too wide, or too narrow rather. So if we change that and then run it, there we go. So I don't know if you guys know this, but if you set the speed to 0 for your turtles, it kind of draws super fast immediately without actually animating the turtle. So if you want to super speed up your turtle programs, do that. Okay, so that looks pretty much dead on for what we have up here. So if we want to draw both of these on the same grid, what we can do is just call it twice. So we'll call draw spiral Alex 90 and draw spiral Alex 89. Now what's going to happen here is when it gets to the end of this one, it'll start drawing the other one. So not perfect. We would have to, if we wanted to make a proper copy of this exact image with both of these spirals on there, we would have to position the turtle in the exact places we want them to start in. And to be honest, our window is not big enough for to match this image. It's just not wide enough, so we couldn't even fit exactly the same picture on there, but you have the general idea here. So again, here's our draw spiral definition, our function for draw spiral, and that will use a turtle T to draw a square shaped spiral with, oh, let's draw it, to draw a spiral with angle. Okay, there we go. And then we just called that down here and then call our main function, and that's it.